All right, we're going to take a look at slope and what it means, and it's called a rate of change. And really what we're looking at is how does the x value and the y value change from point to point. All right, so here we have a line graphed already. We've got 2 points identified. A is at 3, 2, right here, and B is at 5, 5 up here, okay? All right, and what we're looking at is how does this change from one to another? All right, so slope by counting is pretty easy to do. You would walk from one point to another, and your direction up is positive, down is negative, and your direction right is positive and left is negative. Now, slope is rise over run, and it's what we call the change in the y values, because if you rise, you're going up and down. That means you're changing how y is affected, which is our vertical axis. And the run is the change in the x values, which is movement left or right. We call the change delta y, and we've denoted by a little delta symbol, which is a Greek letter for change, and delta x, and they look like triangles. So delta y over delta x means the change in y, change in x, the rise over run. So if I were going to walk from A to B, I'm going to go up 1, 2, 3, and I went in a positive direction because I went up. Now if I'm going to walk over to B, I'm going to go to the right, and I'm going to go right from where I am, and first step off is 1, 2, and now I'm at B, and I went to the right, and that's a positive 2. So my slope in this case is positive 3 over 2. Or you can just say 3 over 2 because it's understood to be positive when you don't print a sign. Now, this is an oblique line, which means it's just slanting, okay? It's an increasing line. It means that as we're moving left to right, it goes upward. So all lines that as we move left to right, the same as which we read, when we encounter the line, we would be moving up. That's a positive slope. So there are 2 ways you can do this, by counting and calculating, which I'll show you next. And you also intuitively can see that this line's increasing, so therefore the slope I get by counting or calculating should be positive. Now, our points were A, 3, 2, and our other point was B, 5, 5. So the calculating method for calculating slope, okay, is taking the y values and subtracting them. Instead of getting into a whole formula, just the change in y means subtract the y's. And the change in x, which is a denominator, is you're subtracting x. That's rise over run. It's just in a different wording. So remember, this is our x, that's our y. Remember, it's xy as our coordinate pair, xy. So if I'm going to do my slope and calculate it, I have to choose the y from one of these 2 points, and I'm going to choose it from my first point. I like to move left to right. So my first y value is 2. I have to subtract the y value from my second point. That's my change in y's. That's my subtracting y's. Now I'm going to put that over my subtraction of the x's. But because I took my y from the first point, I have to take my x from this first point also. If I take my x from the other point, you'll get the wrong slope. So you always go back to where you started. So I'm going to take my x from the same point that I first took my y, which is 3, and I'm going to subtract the x from my second point, which is also 5. And now I'm going to do a little calculating. In my numerator, 2 minus 5 is negative 3. Watch your signs. And in the denominator, 3 minus 5 is negative 2. Now you're going to simplify. A negative divided by a negative is a positive, and it just is 3 over 2. Never, never write your slope as a decimal. You always leave it as a fraction, and that's it, in reduced form. And 3 over 2 is as reduced as it can get. All right, so that is my slope. And as you can see, when I counted my slope, it was 3 over 2. And when I calculate my slope, it is also 3 over 2. If you don't want to write the positive sign, you can leave it off and just write it as 3 over 2. All right, let's take a look at another problem. Okay. Let's take a look at a line that is decreasing. So if our line is decreasing, again, it is an oblique line. It is slanted, but it's going downward as we encounter it. So if we move left to right, we hit the line, we're going downward in this line. We're not going upward. So we are expecting a negative slope. So our 2 points here are C and D, okay? C is at 3, 2, and D is at 5, negative 5. All right, so let's count first. Let's walk from, you can walk in either way you want, C to D. I usually start on my leftmost side and move to my right, but it's up to you. So I'm going to move downward from C to D. I'm going to go down 1, 2, 3, 4, 5, 6, 7. And I went down, so it's negative 7. That got me to the same level as D, almost like taking an elevator to that floor. Now I'm going to move over 1, 2 to the right, so that's positive. So my slope is negative 7 over 2. Now if you had walked up from D to C, you'd go 1, 2, 3, 4, 5, 6, 7, positive, but then 2 would be to the left, so negative. So you would have had a positive 7 over negative 2, and we just always throw the numerator, gets the negative sign. We throw it up there, and we take it off the denominator. All right, now for calculating, okay, our slope is our change in y over change in x, which means we're subtracting the y's over subtraction of the x's. So I'm going to start with my y and my c value to my D point. So I'm going to do 2 minus, that's a negative 5. It has nothing to do with the minus sign. So enclose it in parentheses and keep the negative on the 5. Then I'm going to subtract my x's. So since I started with 2 in point C, I have to start with 3 in point C. So 3 minus 5, so these two get subtracted. All right, cleaning this up, it's 2 plus 5 over 3 minus 5. So my slope is 2 plus 5 is 7. 3 minus 5 is negative 2. And as we said, we take this negative sign and we put it in the numerator and we keep the denominator positive. So it comes out the same if you count versus calculate. And you did expect a negative slope since it was a decreasing line. All right, let's take a look at our vertical lines. Now, as we remember, vertical lines have an undefined slope, which means it's a number divided by 0. So it doesn't matter what the number is. Division by 0 is illegal. It doesn't happen. You can't take something you have that exists and divide it into nothing, because that doesn't happen. It exists, so therefore you can't divide it into no parts. So we will do the same process of counting. Let's walk from E to F. So it's rise over run. Remember, our slope is rise over run. Change in y over change in x. So let's count from E to F. And we're going to go rise first. So we're going to go 1, 2, 3, 4. And we went downward, so a negative 4. But we cannot move left or right. So it's a 0 for the movement left or right. So therefore our slope in this case is negative 4 over 0. Now, if you reversed it and you went upwards, 1, 2, 3, 4, and went up that way, as opposed to down this way, then your slope would be positive 4 over 0. But either way, this results in undefined. So now, how do we actually write it? We do want to show our calculation. We do want to show our count and our division by 0, but our final answer has to be undefined for the slope. All right, calculating. All right, our points were E at 3, 2, and F at 3, negative 2. Okay, so we're going to do our slope is the change in y over the change in x. I'm going to take the y from E, which is 2. I'm going to subtract the y from F, which is a negative. Remember, it has nothing to do with the minus sign. Then I'm going to go get the x from E. I'm going to subtract the x from F. I'm going to clean this up, and I'm going to get 2 plus 2 over 0. So our slope is 4 over 0, which is undefined. So that's what you want to write as your final answer for slope, whether you're calculating or counting. So all vertical lines have an undefined slope. So if you do see a vertical line and you don't want to go through the counting and calculating and you have it memorized and it makes sense now, as soon as you see a vertical line, its slope is undefined. All right, let's look at our typical horizontal line. We have a point H at negative 1, 2. We have a point G at negative 3, 2. Okay, and let's try our rise over run. Okay, delta y over delta x, rise over run. And we're going to walk from one point to another. So let's walk from H to G, and I try to go up or down, and when I do that, it takes me off the line. So I cannot move up or down. I cannot rise in a positive or negative direction. But I can run as much as I want. So I'm going to go, can't go up, can't go down, so I'm here still. So I'm going to go to the right to get to G, and I'm going to go 1, 2, 3, 4, and it's positive. So anything divided into a 0 is 0, or 0 divided by any number is 0, so our slope is 0. So another recognition is that all horizontal lines have 0 slope. All right, so what if we calculate this? Well, those are our points. So remember, our slope is change in y over change in x. So subtract our y's. So I'll start with the y in H, which is 2. Subtract the y in G, which is 2. Go back and get the x from the same point I started with. So it's negative 1 minus. And I'm going to subtract the x from the other point. So negative 1 minus the negative 3. Well, 2 minus 2 is 0. Negative 1, that becomes plus 3, is 2. Okay. And when we do that, we wind up with 0. Okay, and I see here I should have had this as a positive 3. So either way, though, we're going to get it. That should have been a positive, so 4. All right. But again, either way, it doesn't matter how much we rise or run. When our numerator is 0, any number divided into our numerator is going to be 0. But always check calculations. So our slope in counting is 0. Our slope in calculating is 0. All horizontal lines have a 0 slope. All right, so as a summary, you'll have this for your notes. A line that increases has a positive slope. Okay, so if we have an increasing line, positive slope. If we have a decreasing line, it's a negative slope. If we have a horizontal line, it's a 0 slope. And if we have a vertical line here, we have a undefined slope. And you don't have to say slope, you just say undefined once they ask for slope. All right, so positive slope increasing, negative slope decreasing, oblique lines, they're slanted, 0 for horizontal, and undefined for a vertical line. All right, then we get into rate of change. Rate of change is just another name for slope, and that comes more into a word problem. So if I want to know the rate of change, the word slope will not appear in a word problem for something like this. All we have to do is look at the table, and we have to just find out what the difference is as we go from x to y in each step. So as we move through the x's from -3 to -1, we change by adding 1. If we go from -2 to -1, we change by adding 1. If we go from -1 to 0, we change by adding 1, and it keeps going. So as you can see, the change in the x is equal to +1. Now let's look at the y. You don't even have to do a lot of weird calculations like we just did. Let's look from this point to point. Our x's are increasing by 1s. So what do our y's do? So if we go from -1 to -4, we took away 3. We go from -4 to -7, we took away 3. From -7 to -10, we took away 3. And so on, and so on. And that's our change in y. It's -3. So what's our slope? Well, our slope is change in y over change in x. That's our rate of change. So how did we change? Our y was -3. Our x was +1. So it comes out to a -3. For every move on x, we changed y by 3 by decreasing. Or for every decrease in y by 3, x went up 1. That's what rate of change is. So slope is a rate of change. And now let's apply it to something that's more tangible. All right, the Internet Cafe. Table shows the cost of using a computer at an Internet Cafe for an amount of time. Find the rate of change. We know this is slope. In cost with respect to time. So we want to know the change in cost with respect to time. So this is our y, and time is our x. So if you want, you can just say, all right, time is x, y is our cost. So let's see. So how does our time change? Well, from 2 to 4, it goes up by 2. From 4 to 6, it goes up by 2. So our change in time, which is our x, our delta x actually, is 2, positive. Now let's look at our cost in dollars. As we go from 7 to 4, we increase by 7. If we go from 7 to 14, as we go from 14 to 21, it increases by $7. So our cost change, which is our delta y, is $7. So now what we have to do is put this in correctly written up for our rate of change. Okay, so our rate of change is $7 over 2. So that's what it looks like more mathematically for slope. But for us, what we want to say is it increases $7 for every 2 hours. And that's our final answer. And this is the work that supports it.